on this graph, the red lines here, so I'm going to highlight those. That is the actual graph of the hyperbola. So there's a lot of stuff going on here. So this red line here, that's what we're looking at for the hyperbola. So a hyperbola is going to have vertices at these points right here. I didn't mark this on here. It actually also has a center right there between the 2 points. The center is actually not on the graph here. It's the point between those 2 vertices. The part that they bend. Yeah. So like on this case it's the same. But if this was shifted up or down, then it would be that bend right there. That point where it turns from going to the right back to the left. And so hyperbolas, they look a little bit like parabolas that are sideways, but they are not parabolas that are sideways. We're going to actually see parabolas that are sideways tomorrow. But a parabola is going to have more of a U shape to it. Hyperbolas have what we call slant asymptotes. So we have an asymptote, but typically we have only looked at like vertical asymptotes so far, where you get closer and closer to a vertical line. These have slant asymptotes, so as this approaches this direction, it's going to get closer and closer and closer to that vertical line. So like if I graph a hyperbola on Desmos, if I graph x squared over 5 plus minus, you don't know what their equations look like yet, but I do, so divided by 10 equals 1. So like if I look at this, I can see these 2 curves here, but if you zoom way out, it's going to look like an X. If you zoom way far out, because as this line increases here, it's getting closer and closer and closer to a vertical or a slanted line there. So any parabola, if you can zoom out far enough, it ends up looking like an X. It's not going to whenever you're right here, but it will if you zoom really far out. I may have said parabola, I meant hyperbola there. So this is the general shape of what we have. The transverse axis is the axis of symmetry that this actually crosses. The conjugate axis is the one that it does not cross at all. Don't worry too much about that, because we're going to go really light on graphing these. I'm not going to ask you a lot of that information. We kind of skim over these. Mostly, they do have some application and some things that we could get into, but we just don't have time because we should already be at trig stuff and we're not yet. So we are going to move through this pretty quickly. So, standard form of a hyperbola that opens to the left and the right is going to look like this. Always have to double check myself on these because I get them backwards. Alright, so left and right is going to look like this. X minus h squared over a squared minus y minus k squared over b squared equals 1. So, this looks just like an ellipse except for one thing. What's the difference? You have a minus instead of a plus. I think it's pretty crazy and kind of cool that just that one sign change can take it looking like an oval to looking like this stuff, which is totally different looking. So the center is just like it has been for the circles and the ellipses. It's just going to be HK. The center is that point that's not actually on the graph. It's between those two. And so if your hyperbola opens to the left and the right, and I'll show you what the other one looks like in a second so you'll know the difference. If it opens to the left and right, then we need to go to the left and right of our center to get to our vertices. So we're going to look underneath our X, and we're going to have H plus or minus A, K. So what that means is, like, in this particular case, that number under my X was probably a 1 because I went to the left 1 and to the right 1. So a lot like with your ellipses, you'd go left 1, right 1, and then you would graph your points for your ellipses. You do the same here, but instead those are your points for your vertices. I guess they're vertices on the ellipses too. It's just you only have them in left and right here. And then your transverse axis is the axis of symmetry where this would fold in half right here, the one that actually crosses those points. And so it is going to be a y equals because it is a horizontal line. And the y coordinate of that center is k, so it's going to be y equals k. And I'm not going to ask you about the conjugate axis. I'm not going to ask you for those equations of the asymptotes. I could do all of that, but we're scaling it back a little bit so we can get through it a little more quickly. Questions so far? Yes. Mm-hmm. Yes. Y equals K is a horizontal line. Yeah. it's easy to get that backwards, but Y equals K is a horizontal line. So it's still this horizontal line right here. Okay? All right, so the next one is going to be very similar but slightly different. So here, my X came first and was positive. The minus was in front of the Y stuff. If it opens up and down, it's switched. So it would look like this. Y minus, Y minus K squared over B squared minus X minus H squared over A squared equals 1. So it's flipped. What you have to be careful of here, your center, the X coordinate is still whatever number you have with the X. So that's still your H, and this is your K, which a lot of students will do backwards because now the Y is first, so they'll just say KH, but that would be incorrect. And so your center would be right here. In this case, to get to the vertices, you're going to have to go up or down. So if you go up or down, it's going to change your Y coordinates, and it's going to, the number underneath of that Y is your B squared. So it's going to be HK plus or minus B. So a lot like when you're graphing the ellipses, that number underneath the Y, you're going to go up or down the square root of that number. And this time, that transverse axis, the axis that cuts through right here, it is vertical. And so vertical lines have a line of X equals, and the X coordinate of that center is H. So it's going to be X equals H. Okay, questions? Okay, so the good news about this is that there's going to be very, very little difference in putting these problems in standard form as there was ellipses. So if you could do ellipses, there's only a tiny difference to do hyperbolas. So we're going to do the same thing that we did before. We're going to have group our x's together. Move that 55 over to the other side. And whenever we factor out here, we got to factor out a 9 out of our x's. So I've got x minus 6x squared minus 6x. I'm going to put a plus blank here. And when I'm factoring out of my y's, I've got a -4, so I need to factor out the -4. So I'm taking the negative out with it. I'm going to have y squared plus 10y plus blank. And this is going to equal 55 plus blank plus blank. So the only real difference here is that you're going to have one of your, either your x squared or your y squared is going to be negative. And you're going to have to factor out a negative whenever you deal with that. Okay? So we will complete the square. We'll have x minus 3 squared. 3 squared is 9, so we put that in the blank here. What number should I add to the other side? 81, because I have to take this 9 and multiply it by the 9 that's out front. Okay, then we've got our -4. We're going to have y plus 5 squared here. And then I've got to square that 5 to get this 25 that goes here in the blank. What number do I add to the other side? -100, because I got to do 25 times that -4, which is -100. So whenever I do this, let's see, it's going to get me 36, I believe. Is that right? And just like the ellipses, last step, I'm about out jacking in for some more. Alright, so 9 and 36 I can reduce. It's going to be x minus 3 squared over 4. 4 and 36 I can reduce. Y plus 5 squared over 9 equals 1. And we are going to sketch graphs for these, but they're going to be very basic graphs. So what I need for you for the graph is so whenever you're graphing, I want you to have 3 things. I want you to have the center, vertices, and then opening correctly. So let me show you what I mean by that. So what is the center of this one? 3, -5. So 3, -5 is my center. I need to know, is this a hyperbola that's going to open to the left and the right or up and down? Nope. It is left and right. So if your x is positive, so if this is the one that comes first is positive, it is going to be left and right. If the y is positive, it's going to be up and down. So this one is going to be left and right. So I'm going to look at my x. I'm going to look underneath. I got a 4. I'm going to take the square root of it, which is 2. I'm going to go to the right 2 and the left 2, since this one opens left and right. And I'm just going to open, I'm going to draw some sort of curve that opens this direction. So the vertices would be at 4, -5, and 1, -5. No, 5, -5, and 1, -5. So you're just, from that center, you go 2 to the right and 2 to the left. You don't necessarily have to give the points, but you just have to graph them correctly. Yeah. Now, it does affect this. Like I'm going to flip back over Desmos just to give you a preview of this. So if I try to graph that one on Desmos, oh wait. If I graph this one on Desmos, x minus 3 squared over 4 minus 9 plus 5 squared over 9 equals 1. So if I graph this on Desmos, this 9 does matter. It does do something to the graph. Like if I change it to a 16 or a 50, you can see it makes it much taller and skinnier. If I change it to a 2, it actually makes it shorter there. So it does affect it. I just don't want to go into all of the work it takes to know exactly what happens there. So right now, I just want you to be able to graph it and have it opening in the correct direction. You don't have to go into a lot of great detail on how to graph it. I could teach you how to find the equation of those slant asymptotes and graph it much more precisely, but we're going to skip it for the sake of time. Okay, questions? All right, I got one more that we're going to do. You can see here we got a much shorter equation. How do I know, just from looking at this, that this is a hyperbola? Other than it's on the hyperbola notes and it would not make any sense. I've got a negative x squared, but a positive y squared. So anytime your x and y's have opposite, x squared and y squared have opposite signs and they're on the same side of the equation, then it's going to be a hyperbola. Even if they're the same number, like if I had negative 3x squared plus 3y squared minus 7y plus 2 equals 4, or something like that, that would still be a hyperbola, even if it's the same number but opposite signs, right? So if I have opposite signs, I know just by looking at it that it's a hyperbola. Okay. So in this case, my y squared is positive, so I'm going to keep it first. And since it does not have a y that goes with it, I am not going to complete the square for that y. So if you don't have like a 2y or an 8y or something like that, just don't complete the square. Leave it as that y squared. For the x squareds, I'm going to need to factor out that negative 5. So I'm going to factor out that negative 5, and that will leave me with x squared plus 4x plus blank equals 50, and I'm just going to put 1 plus blank here since I only have to complete the square once. And in general, if your y squared is a 1 positive, I would put it first whenever you're doing this, although technically you can do it the other way too. So we need to complete the square here. So we'll have x plus 2 squared when we divide that 4 by 2. Then we'll square 2 and we'll get 4, which we'll put here. What do we have to add to the other side? Negative 20, because we got to do 4 times that negative 5 that we factored out. So we're going to get this is equal to 30. Okay, and we're going to divide everything by 30. And when I do that, I'm going to get y squared over 30 minus 5 over 30 is going to reduce to be 1/6. So I'll get x plus 2 squared over 6 equals 1. Is this one going to get open to the left and right or up and down? This is up and down, so we're dealing with something that looks like this. What is my center? Wrong, but I'm glad you said it. -2, 0. because I'm glad that Mia said 0, -2, because that's, even sometimes I get that wrong. Because it's usually that first number, but the 2 is with the x, so it's your x coordinate. And the 0 is with the y, so it's your y coordinate. So be careful with these because it's really easy to get those wrong. So my center is at -2, 0, so it's right here. Since I'm going up and down, I want to look underneath my y to figure out how much to go up or down. So I need to take the square root of 30, and we are just going to estimate this for our graph. So square root of 30 is somewhere between 5 and 6. What is? Somebody type that in your calculator and tell me what square root of 30 is. 5.47. 5.5 will be close enough for our estimate here. So from this point, we need to go up 5.5 and down about 5.5 here. And we need to just draw some curves that open up and down. Yeah, we could be more precise with that, but we're going to say this is good enough for right now. Okay, questions? Yes? If the y is the part that's positive. If the x is positive, it'll be left and right.
How do I know? And since there's a negative there, and makes the y.
Yeah, so since your negative was with your x squared to begin with, whenever you start the problem out, then you're going to have, I would put the x second whenever you complete the square and everything.
What is the OP correctly again?
That's just whether you draw it the right direction. So, like here, whenever you graph this, your vertices need to go up and down, and then you draw that it opens up and down for that one. Yeah. Yes? Okay, so because the y squared is positive here, we know that this is going to open up or down, so it means our vertices, we're going to have to go up or down to find them. So if you're going up or down, you want to look underneath your y coordinate. Like on the last one, we were going left and right. We looked at the value underneath our x coordinate. So our y, we have a 30 here. So we're going to take the square root of 30, which didn't go evenly, so we just used our calculator to estimate. On a quiz or test, I will try to have something that goes evenly there. And so from the center, you just go up square root of 30, which is about 5.5, and down square root of 30, which is about 5.5. And you're going to draw your curves in. Yes, if your x is first, you use that one, and that'll move it left or right since it's the x. Yeah. And if the y is first, that'll move it up or down. Okay? All right, questions? Okay, so your assignment is again going to come from the textbook. It's on Canvas for you. 15 through 22. For each one, it's going to have directions that tell you to do more than this, but I want you to find the center, the vertices, and scale.